In the next 15 to 20 minutes, I will be showing you approximately 25 topics along with the previous year questions. These topics will cover 80 to 100 marks in NEET 2026 physics. My dear NEET aspirants, for sure you can expect the questions from these topics. So do not leave any of these topics. Do not miss out just 1 second from this particular video. Make sure you smash the like button and make sure you share it with your friends also. First one, let's dive into the session. First one, forward bias. My dear NEET aspirants, this is a semiconductor over here, P-type semiconductor, N-type semiconductor. You just have to remember one thing. If the positive terminal of the battery is connected to P side, negative terminal of the battery is connected to N side, this is what we call the forward bias. And in case of forward bias, this is called depletion region. This depletion region decreases. That's it. And one more important thing. In case of forward bias, this semiconductor behaves like a simple wire. Current easily flows. Means the resistance over here is zero. That's it. And you can see tons and tons of questions have been asked on this particular information that I gave you. NEET 2020. The increase in the depletion region in PN junction diode is due to, and this is, my dear NEET aspirants, in the reverse bias. This is in the reverse bias. Let me just show you first reverse bias. This is the P-type semiconductor. This is N-type semiconductor. If positive terminal, this is negative terminal. If negative terminal is connected to P side and positive terminal is connected to N side, this is positive, this is negative. This is what we call reverse bias. In case of reverse bias, it behaves like an open wire and resistance is infinity. And my dear NEET aspirants, we say here depletion region increases. That's it. Now take a look. NEET 2020 question. The increase in the depletion region in PN junction diode is due to the, I would say, reverse bias. Just one-liner question. NEET 2017, my dear NEET aspirants, which one of the following represents the forward bias only? See, forward bias means when P side is connected to higher potential and N side is connected to lower potential. This is P, this is N. Okay, so this is, my dear NEET aspirants, P, N. This is P, this is N. This is P, this is N. Now guys, see, in this case, P side is connected to 3 and N side is connected to 5. This is reverse bias. Okay. So P side is connected to 0. N side is connected to -2. 0 is greater than -2. This is forward bias. This is connected to -4. This is connected to -3. This is again reverse bias, because in case of forward bias, P side is connected to higher potential. Here -2, here +2. This is again reverse bias. So option B is the correct option. Let's move on to the next one, my dear NEET aspirants. When it comes to, in this particular case, ammeter, conversion of galvanometer into an ammeter. My dear NEET aspirants, you have got a galvanometer over here. If you want to convert this galvanometer into an ammeter, ammeter is a device which measures the current. So you connect a shunt resistance in parallel to this, okay, this shunt resistance. And directly remember, the value of this shunt resistance is basically Ig into G upon I minus Ig. Ig is the current flowing in the galvanometer. I minus Ig is the current flowing in the shunt resistance. Now there is a question which was asked over here. Now you are given a galvanometer which has resistance 100 ohms, is used to measure 10 ampere current. Basically, you are supposed to find the value of shunt in ammeter. Shunt is Ig into G upon I minus Ig. I is given over here 10 ampere, okay. G is the resistance of galvanometer, that is given as 100 ohms. And then net current is 50 ampere minus 10 ampere, I minus Ig. So this came out to be 25 ohms. Just one liner. Next, my dear NEET aspirants, conversion of galvanometer into a voltmeter. So my dear NEET aspirants, this is a voltmeter. When you attach a shunt resistance in series to the galvanometer, it becomes voltmeter. Here, the value of the shunt resistance is this, V divided by Ig minus G. Like you have a question over here. In this particular case, you are supposed to find the resistance of the voltmeter over here. So directly you can read the question, you can apply the formula. S is equal to E divided by Ig minus G. So this voltage across the voltmeter is given as 30 volts. So here it is 30, and current is given as 30 milliampere. It will be mentioned over here. Okay, current is given as 30 milliampere. 30 milliampere is 30 into 10 raised to power minus 3 minus, I would say, 100. So this came out to be 900 ohms directly. Then, boys and girls, meter bridge. Meter bridge is an instrument which is used to measure the unknown resistance, my dear NEET aspirants. Okay, So this is the known resistance, this is the unknown resistance, and there is a 100-meter wire connected over here. Now, in this particular case, this is a galvanometer. We keep on scrolling this galvanometer, we keep on scrolling this jockey until we get the balance point. Let's suppose we get the balance point at length L. So this distance is going to be 100 minus L. So directly in this particular case, balance point is that length when no current flows through the galvanometer. When no current flows through the galvanometer, my dear NEET aspirants, in case of meter bridge, you will remember this equation. That is P divided by this Q upon this L upon 100 minus L. This is the equation of, I would say, meter bridge. Now, this helps you to find the unknown resistance. Like this meter bridge is in a balanced state. This is 5 ohm, this is X. This balanced length is, that is 20. So this will be 100 minus 20, that is 80. You have to find the value of this unknown resistance. What will you say? 5 divided by 20. Okay, you can say this 5 divided by 20, or you can say 5 divided by X also. It's one and the same thing. Okay, then upon this X divided by 100 minus 20. This divided by this will be equals to this divided by this. So from this you can solve, you will get the value of X is equal to 20 ohms. This is the concept of meter bridge. Force between two parallel wires, my dear NEET aspirants. If you have got two parallel wires, current flowing in this wire is I1, current flowing in this wire is I2. And these two wires are attracting each other with a force. Now, this is the force acting on the unit length of the wire. Keep that thing in your mind. So this is the force between the two parallel wires. Mu naught I1 I2 divided by 2 pi into R. Now, boys and girls, this is the question which was asked previously. This is in the NEET 2020 question. You have got three wires, this B wire, C wire, A wire coming out of the board. You are supposed to find the net force applied on this middle wire. Now we know that if this is the wire in which current I is flowing, here current I is flowing, here current I is flowing. On this middle wire, this C wire is going to attract it with a force F. This A wire is also going to attract it with a force F. Now resultant of this F and F, this is going to be root 2F. Now root 2F, I recently told you this F will be, that is mu naught I1 I2 divided by 2 pi R. So here mu naught I square, because I into I becomes I square divided by 2 pi into D. Why? Because when you have two forces at an angle of 90 degree, resultant in that case is going to be root 2 into F, my dear NEET aspirants. Then boys and girls, we will be moving on to the next topic. That is what we call the transformer. When it comes to the transformers, we say transformer is a device. This is a transformer which stabilizes the voltage. Okay, which increases the voltage or decreases the voltage. Let's suppose this is what we call the primary coil of the transformer. In this primary coil, we send the current, that is what we call the primary current. And here, voltage in the primary coil is V input. And this is the number of turns in the primary coil. Then this magnetic field or this current moves to the secondary coil. Here, this secondary coil provides as the output voltage, output current, okay, and number of turns in the secondary coil is Ns. And my dear NEET aspirants, when current flows through this coil, it creates magnetic field. That magnetic field goes over here. So flux is created over here. So that flux is transferred to the secondary coil. If somebody asks you what is the voltage in the secondary coil, you will be saying voltage output will be equals to the voltage input into number of turns in the secondary coil divided by number of turns in the primary coil. Similarly, output flux in the secondary coil is going to be flux in the primary coil into number of turns in the secondary coil upon number of turns in the primary coil. Now this is a question. In this question, number of turns in primary coil is given as 500. Number of turns in secondary coil is given as, I would say, 5000. Input voltage is given as 20. You are supposed to find output voltage. Output voltage of the transformer is simply V input Ns divided by Np. Just put the values. This is 25,000 divided by 500. It will come out to be 200 volts. I hope this is crystal and clear. Faraday's law of electromagnetic induction, my dear NEET aspirants. Faraday's law of electromagnetic induction says that whenever magnetic flux or magnetic field through the coil changes, EMF is induced in that coil. Directly remember. And this EMF is minus d phi by dt. And this flux is, by the way, magnetic field into area. You can write it like this. Now, let's move on to the question. You have a ring over here. This ring is placed in a magnetic field. Okay, this ring is placed in a magnetic field. This magnetic field is given as B naught plus alpha T. You are supposed to find if this magnetic field is changing with respect to time. So how much flux, how much EMF is being induced in this coil? So how will you find the EMF, my dear NEET aspirants? EMF is going to be minus d phi by dt. So minus d by dt of phi means magnetic field into area. Instead of magnetic field, you will be putting its value, that is B naught plus alpha t, into area of the coil, that is pi r square. Now pi r square is constant, take this pi r square out. So d divided by dt of this magnetic, this B naught is constant, magnetic differentiation of B naught is 0, and differentiation of alpha t will be alpha. So final answer is pi minus pi r square into alpha. Then guys, you have this particular concept, very important. In this particular case, this is what we call the cord. Okay, current is flowing in the cord. This is called a straight line. This is called a semicircular wire. This is again cord. This is semicircular. This is a straight wire. Now guys, you have to find the net magnetic field at the center. First of all, magnetic field due to a cord at the center is mu naught I by 8r. Magnetic field due to semicircle is mu naught I by 4r. Okay. Now guys, here we say magnetic field due to this wire at center will be 0, because if the point lies on the axis of the wire, then magnetic field at that point is 0. Magnetic field due to this straight wire at this point is also 0, because this lies on its axis. Magnetic field due to this portion of the wire is also 0. Now magnetic field will be created due to this cord, due to this semicircle, due to this cord. Now guys, what is the magnetic field due to this? Mu naught I divided by 8r, but instead of r, I'll be writing its radius, that is 4r. So 4r. What is the magnetic field due to this semicircle? Mu naught I divided by 4r. Okay, instead of r, I'll be writing its radius, that is 2r. That's why 2r. Then magnetic field due to this cord, that is mu naught I by 8r. Mu naught I by 8r. Its radius is r only. That's why I'm writing r. I hope this is also clear. Magnetic field due to a solenoid, my dear NEET aspirants. Let's suppose you have a solenoid in this particular case. Okay. And we say magnetic field at the center of the solenoid is mu naught n into I. N means number of turns per unit length. This n can be written like this also. Total number of turns divided by total length. So you can say B is equal to mu naught n I divided by L. So magnetic field at the ends of the solenoid is magnetic field inside divided by 2. You can write it like this. Now guys, this was the question asked in NEET 2020. So a solenoid is given, its length is 50 into 10 raised power minus 2 meter. Here it is given in the centimeters. Total number of turns is 100. Current is 2.5 ampere. You have to find the magnetic field inside the solenoid. Mu naught n I divided by L. Just put the values and get the answer. Equipotential surfaces. Very important. So many times questions have been asked from this particular topic. We say that surface upon which potential is same everywhere. That is known as equipotential surface. Like for a point charge, if this is a point charge, we say equipotential surface will be the spherical. Okay, for a point charge, draw a sphere around it, that will be equipotential surface. The potential difference between the 2 points on equipotential surface is always 0. Because if the potential at every point on equipotential surface is same, so potential difference is going to be 0. Then, electric field is perpendicular. This is the question from NEET 2022. This was asked in NEET 2022. Electric field is perpendicular to the equipotential surface at all the points. If this is a charge, so because of this charge, electric field is away from the charge. Around this is the equipotential surface. What is the angle between electric field and equipotential surface? 90. That means perpendicular. No work is done by the electric force in moving the charge on equipotential surface. If you move the charge from equipotential surface from this point to this point, so no work is done. No work is done by the electric force. Work done is 0. Next concept, my dear NEET aspirants. Potential due to a solid sphere. So boys and girls, you have got over here a sphere. In the sphere, you have got, I would say, radius r. You are supposed to tell me potential outside, potential on the surface, potential inside. Due to the hollow sphere, okay, this is a solid sphere, sorry. So due to the solid sphere, potential outside will be kq by r. Q is the charge, r is the distance from the center to that point. On the surface, it is kq by capital R. Inside at any point, it is kq divided by 2r cube, 3r square minus r square. And exactly at the center, potential is 3 by 2 kq by r. And potential at the center is greater than potential at the surface because this is 3 by 2. 3 by 2 means 1.5. And its graph is extremely important, my dear NEET aspirants. This is the graph of potential. This is this is the graph of potential versus R. So it would be something like this. So this is the center. At x is equal to 0, potential is maximum 3 by 2 kq by r. Then it goes down. This is the potential at the surface kq by r. Then outside it is V is inversely proportional to small r, small r. I hope this is also crystal and clear. Next is mean free path, my dear NEET aspirants. It is defined as the average distance a gas molecule travels before colliding with another molecule. Let's suppose this is the gas molecule. It makes the collision with another molecule over here. Then after some time, it makes the next collision here. So this distance between these two successive collisions, this is what we call average. This is what we call the mean free path, my dear NEET aspirants. And this mean free path is actually equal to, I would say, kt under root of root 2 pi d square into p. This is what we call the mean free path. L means the mean free path, T is the absolute temperature, P is pressure, D is the diameter of the molecule, K is Boltzmann's constant, my dear NEET aspirants. Okay, so you can clearly see in this particular case, okay, average mean free path directly. This is the formula you can see over here. And what is the, this was the question asked in NEET 2020, and this was the question asked in NEET 2020. What is the relation between this mean free path and D? So L is inversely proportional to D square. So I would say option B in this particular case. Okay, graph conversion, very, very important, my dear NEET aspirants, from the thermodynamics chapter. Listen to me very carefully. So convert PV graph into PT graph. This is pressure versus volume graph. Okay, you have to convert this to the PT graph. Now guys, if you take a look at this AB, in this AB, what is constant? Pressure is constant. In AB, pressure is constant. We will apply ideal gas equation. PV is equal to nRT. Now guys, in this particular case, P is constant, N is constant, R is constant. So V is proportional to T. So means if V increases, temperature increases. Now see, it's PT graph. So if volume is increasing from here to here, volume is increasing. So temperature must also increase. So this is going to be the AB graph in PT. Because here in this case, temperature is also increasing. Then in BC, you can clearly see volume is constant. Volume is constant. PV is equal to nRT. This is constant. These two are constant. P is directly proportional to temperature. If pressure increases, temperature increases. Now see, from here to here, clearly pressure is increasing. So temperature must increase. Now see, this will be the graph BC. Why? Because in this particular case, pressure is increasing. See, pressure is increasing. Okay. Then, my dear NEET aspirants, CD. In case of this CD, again pressure is constant. Pressure is constant. Again, volume is proportional to temperature. So it means if volume decreases, temperature decreases. Because from here to here, volume is decreasing. So temperature must decrease. So it should go back. This is basically the graph CD. Why? Because see, in this case, temperature is decreasing. In this case, volume is decreasing. Then we say DA. In case of DA, again, volume is constant. So if volume is constant, again, pressure is proportional to temperature. So if pressure decreases, means temperature decreases. So my dear NEET aspirants, in this case, pressure is decreasing. So temperature must also decrease. So this is temperature is decreasing if it is going over here. So this is going to be the graph. I hope graph conversion is also clear. Then first law of thermodynamics. My dear NEET aspirants, if heat is given to the system, it can be used to either increase the internal energy of the system or to do the work done. Heat given is increase in internal energy plus work done. So we say dq is equal to du plus dw. Let's suppose you have a container over here in which gas is present, in which piston is there. Now, if you supply the heat to the system in this particular case, so my dear NEET aspirants, if heat is given to the gas becomes hotter, okay? So internal energy increases. The gas also expands, due to which piston pushes the gas in the upward direction. So basically work is also done, and we say internal energy of the gas is also stored over here. Okay, this is a question on this. So a system is provided 200 calories of heat. The work done by the system on the surrounding is 40 joules. Now guys, see, so if it is 200 calories of heat, So 1 calorie is 4.2 joules. 200 calories will be 200 into 4.2. That means heat given to the system is, I would say, that is 840 joules. Now, work done by the system in this particular case, that is given as 40 joules. Okay, work done by the system on the surrounding is 40 joules. You are supposed to tell me then its internal energy is. Now, guys, see, we use first law of thermodynamics. dq is equal to du. The heat supplied goes into the internal energy plus work done. Now, heat supplied is 840 joules. Okay, and internal energy we are supposed to calculate. Work done in this case is 40. So this will come out to be, du will come out to be, that is 800 joules in this particular case. Okay. Then, my dear NEET aspirants, take a look at this particular topic. That is viscosity over here. Listen to me very carefully. Listen to me very carefully. Viscosity is defined as the measure of resistance to the fluid. So basically, when fluid moves, so these are the two, I would say, these are the two liquid layers. When these two basically move, they create a friction. Like when the two bodies move, they create a friction on each other. Similarly, when two liquid layers move, they create a friction on each other. That is what we call the viscosity, viscous friction. Okay, so this, if this is having the velocity v naught plus delta v, so if this wants to move forward, on this friction will act backward. Now, if this wants to basically go backward, friction on this will be basically in the forward direction. So this frictional force is actually equals to, this frictional force is actually equals to, here it is mentioned, that is neta A delta V divided by L, where neta is what we call coefficient of viscosity, A is the area of this liquid layer, delta V is the velocity with which it is moving, and L is the separation between the two liquid layers. L is the separation between the two liquid layers, A is the area, delta V is the velocity with which it is moving. Okay, now there is a question on this basically. Now this is a question of NEET. There is a plate placed on this liquid film. It says that when the oil film, how much force we need to apply. Guys, see, this is going to create the viscous force. This is going to create the friction on this plate in the backward direction. How much force we need to apply so that we can pull this plate in the forward direction. Sir, this external force has to be equal to this frictional force, then only. So this external force must be equal to this cohesive force or frictional force, that is neta A delta V divided by L. Okay, value of neta is this, area is given in the question in this particular case, and D, separation between this width of the film, or separation between the film and this, is given as 10 raised power minus 5 meters. So you can just put the values over here and you will get the frictional force in this case. Next, my dear NEET aspirants, equation of continuity. Equation of continuity simply says, whenever the amount of fluid enters the pipe per second, the amount of fluid entering this pipe every second must be equal to the amount of fluid leaving the pipe every second. Okay, so basically, if pipe becomes narrow, the fluid must speed up. If pipe becomes wide, the fluid must speed down. So here, so we can say this equation of continuity will be simply this here, A1 into V1, area into V1 will be equals to, I would say, A2 into V2. So rate of flow is constant. This is equation of continuity. Now this is a question over here. So radius over here is given as 2 centimeter. Velocity here is given as 20 centimeter per second. Radius is 1 centimeter. It says what is the velocity of fluid at this point. What will you say? A1 into V1 into A2 into V2. Now what is the area over here? That is pi r square. So you can say velocity is 20 over there, and pi into r square, radius over here is 2 centimeters, is equal to, what is the area over here? Pi into r2 square, pi into r2 square. What is the value of r2? That is 1. So 1 square into V2. From here, you will get the value of V2 as 80 centimeters, my dear NEET aspirants. Then you have velocity of efflux. Let's suppose, my dear NEET aspirants, you have a fluid present in the container. You make a hole over here. Then this fluid will come out of this hole with certain velocity. The velocity with which this fluid comes out of the hole, that is what we call the velocity of efflux. Density of liquid in this particular case is given as rho. Now, my dear NEET aspirants, when this liquid comes out of the hole, so basically it follows this projectile path. Now, how much time it is going to take from this point to this point on falling down? How much time this liquid will take in reaching the ground? That is called time of flight. This is the time of flight. That is 2h minus h. H is this height and h is this depth at which hole is being created, divided by g. G is the acceleration due to gravity. And range over here is 2 into h minus h into h. Range means how far it can go, how far this liquid can go. And one more important thing, when is going to be the range maximum? Range will be maximum at h divided by 2. This is also the important point. My dear NEET aspirants, I have covered approximately 25 topics. In these 25 minutes, make sure you smash the like button, and these are very important. Thank you so much.